Hey guys, hope you guys are all doing well at home. I'll try and make this as quick as possible, but I wanted to talk to you guys a little bit about cardiac anatomy and physiology today, and also some cardiac failures that can occur in their causes. So first here, let's get started right away. So this is a heart. This is about the size of a human heart. This is not a human heart. This is a sheep heart, and this sits on the left-hand side of your body like this. Remember your anatomical positions. Okay, so if you notice right away, it's got kind of this membrane around it. And if you remember from early on in the year, we talked about pericardium, right? Parietal pericardium and visceral pericardium. Well, this is the parietal pericardium. It's surrounding the heart. So if you remove that, that exposes the muscular organ of the heart. Okay, well, that is the heart. So the space between this parietal pericardium and the visceral pericardium, that's the pericardial cavity. That has that serous fluid in it, that pericardial fluid that helps reduce friction, allows the heart to beat in a relatively frictionless environment. Okay, but for today, I'm going to use something a little bigger. I'm going to use this. It's a cow heart. So this is a lot larger, wouldn't fit in here, obviously. This belongs to a cow, but it's bigger, so we can see all the structures a lot better in this. Okay. So what I'm going to do now is I'm going to tilt this camera up. So I'm going to change my gloves. I'm going to tilt this camera up so we can get a real good look at this heart. Hopefully I can do this without it falling. Okay. There. Get some gloves on again. Okay. So I want to go over the basic anatomy and the basic physiology of a heart. So the heart is a pump, right? So its job is to push oxygenated blood throughout the body and then return relatively low oxygenated blood and carbon dioxide to the lungs, to get rid of the carbon dioxide and to pick up the oxygen. And it also transports a lot of nutrients like glucose and hormones and all kinds of things. All right, so let's take a look at the heart as it sits in the body. So this, remember your anatomical position, all right? So this right here, this would be the right side and this would be the left side, okay? The right side, left side. You're looking at the top of the heart from where you guys are. You're looking at the top of the heart here, okay? So this is the base, and then this pointy part here, this is the apex. So the base and the apex, okay? This right here, you see that line? That is the interventricular groove, interventricular groove or interventricular sulcus, okay? Lying inside of that, right? So right here, this right here, there's an artery in there, okay? That's the left anterior descending artery, or the LAD, okay? This is also known as the anterior interventricular branch of the left coronary artery. So what can happen here is what is known as the Widowmaker Infarction. An infarction is a kind of a blockage, right? So this, as you can see, this supplies blood to the heart itself. So all the muscles, all the organs of the body, they need blood. Well, the heart is no exception. So this brings oxygenated blood to the heart. If this gets plugged up, doesn't get oxygenated blood, and the heart muscle can die. Okay, so this is all fat. This is pericardial fat up here, right? You don't want a lot of that on your body. Pericardial fat. Up here on top, you can see some structures here, some tubes, this right here. This is an artery. Know that because it's thick-walled, right? Arteries carry blood away from the heart. This is a thick-walled muscular tube. This is the aorta, okay? This is the aorta. Over here, another thick-walled, so that's going to be taking blood away from the heart. That's artery. So that's the pulmonary trunk. This is going to supply the body. This is going to take blood to the lungs. Okay, aorta, pulmonary trunk. These elephant ear looking things here and here, these are called the auricles. These are the auricles here. Okay, so let's get this guy open and we'll take a look inside. I cut this ahead of time to save some time. So look here. So we've got two sides of the heart here. We can see very different chambers. Okay, so very different structures. So this over here, where my thumbs are, that is the right side of the heart. That's the right side of the heart. Its job is to take blood that's low in oxygen and move it to the lungs. Okay? So the blood that is coming back from the body needs to get more oxygen. This side is the pulmonary circuit. Its job is to take blood from the body that's low in oxygen and move it to the lungs. This side here you can see is larger and the wall, the heart wall, is thicker. Okay? So this is the left side. Its job, this is the systemic circuit, its job is to move that oxygenated blood, throughout the rest of the body. Okay? Some other structures we see here, see these little stringy things? These are called Chordae Tendineae. Chordae Tendineae. Chordae Tendineae attach the valves to papillary muscles. See that big muscle there? That's a papillary muscle. Chordae Tendineae attaches this valve, right? This is the bicuspid valve. Attaches the bicuspid valve to papillary muscles. So when this pulls, it closes that really, really tightly. Okay. Over here, on the right side, we've got a valve here. This is the tricuspid valve. Okay, tricuspid valve. Okay, so I think what I'll do is I'll talk about blood flow and kind of name the parts as I do that. I think that's kind of the best way to do this. So heart sits in the body on the left-hand side. Blood returns from the body through the, cut off here, but through the inferior and superior vena cava. So superior vena cava is draining the head and the upper extremities, and the inferior vena cava is bringing blood from the lower body. And it's going to dump into this first chamber here, okay? Now remember, this is together, right? Cut it open, put it like this first chamber here, okay? And this first chamber, that's the right atrium. The right atrium is going to contract, right? You see these muscles in here? These are called pectinate muscles in here. The right atrium is going to contract. That's going to push open this tricuspid valve, flooding the right ventricle. Okay? So now the blood's in the right ventricle. The right ventricle is going to contract, right? Pulling this tricuspid valve closed, so it can't go back up. It's a one-way valve. So the right ventricle is going to contract, and that's going to force the blood out through the pulmonary trunk. And you can see here, this is all connected, right? It's all connected there. See that? Okay, so out the pulmonary trunk. Now inside of the pulmonary trunk, I'll try and get you a good view here. Inside of the pulmonary trunk, there's another valve in there. And that's called the pulmonary semilunar valve. And that's one way, okay? So, recap the pulmonary side, very simple. So blood is going to enter the pulmonary circuit through the superior inferior vena cava into the right atrium. Right atrium is going to contract, push open the tricuspid valve. The right ventricle is going to contract, and it's going to push open the pulmonary semilunar valve. It's going to go out the pulmonary trunk to the right and left pulmonary arteries to the lungs. Okay, now that's relatively low oxygenated blood. Okay, the partial here, I'll write it down for you. The partial pressure of that is about 40 millimeters of mercury. Okay, so about 40 millimeters of mercury. So the partial pressure of the venous bloods, right, oxygen, is about 40 millimeters of mercury. So partial pressure, if you don't remember from chemistry, is just the pressure that would be exerted on the walls, in this case of a vessel, if it was just oxygen present. Okay, so about 40 millimeters of mercury. Okay, so now we've got nice oxygenated blood, and it's got to come back to the heart now. Okay, so we've got the pulmonary circuit has completed its job. Now it's going to come to the systemic circuit. So coming back to the heart, we've got the pulmonary veins. The pulmonary veins, it's cut off here, but the pulmonary veins are going to empty into the left atrium, okay? The left atrium. The left atrium is going to contract. That's going to push open the bicuspid valve, right? And then the left ventricle is going to contract, okay? The left ventricle is going to contract, and that's going to push open the aortic semilunar valve, which is right here. Aortic semilunar valve, and that's going to push the blood out the aorta, and that's going to go to the rest of the body. We've got an ascending and a descending aorta there. Okay. I guess they're mowing outside. Good. All right, keep it going. Okay, so and that's going to go to the rest of the body. Now that blood is high in oxygen. Okay, it's got a partial pressure of about 100 millimeters of mercury. Okay, write that down for you there. So it's got the arterial pressure, right? Partial pressure of oxygen is about 100 millimeters of mercury. Okay, so that's what's going on with the blood as it enters the left side. Okay, so the left side now is going to contract, and that pushes it out the aorta to the rest of the body. Okay, so a recap real quick. So blood is going to enter through the right atrium, right, superior inferior vena cava, right atrium, through the tricuspid valve into the right ventricle. The right ventricle is going to contract out the pulmonary trunk through the pulmonary semilunar valve to the lungs, and then back the pulmonary veins into the left atrium. The left atrium is going to contract, push open the bicuspid valve or the mitral valve. The left atrium the left ventricle is going to contract, push open the aortic semilunar valve, out the aorta of the rest of the body. Okay, so let's go over some parts here again. So let's do the layers. So there's 3 layers of the heart. So this would be the epicardium. Epicardium is the outside. Muscle, myocardium. That's all of the muscle of the heart. And the endocardium, that's the inner layer here. Okay, we got Chordae Tendineae, papillary muscles. Up here in the atria, these are called pectinate muscles up in here. Okay, this stuff here that does not connect to a valve, this is called trabeculae carneae. And one purpose for those is to keep the heart walls from sectioning together when they contract like that. Okay. So now let's talk about the electrical conductance system. So the electrical conductance system, so you're familiar with depolarizations and propagation of charges and conductance of all that. So in order for this system to work, what happens is we've got a sinoatrial node and an SA node, and it's up here on the left atrium. It's going to depolarize, and it's going to send a wave of depolarization around the atria. The atria are going to simultaneously contract, and then that depolarization wave, that conductance, is going to reach an AV node, atrioventricular node. Atrioventricular node. And now it's going to travel down through right and left bundles, and then up the sides, the walls of Purkinje fibers, and then that's going to cause the ventricular walls to contract. Okay, so SA node, atrial contraction, AV node, ventricular contraction. Okay, so that's electrical conductance in a nutshell. So let's talk about some problems that can happen. Oh, this right here, this part will tell you this too. This whole structure here in between the ventricles, that's called the interventricular septum. Okay, the interventricular septum. Okay, so let's talk about some failures that can occur with valves. Okay, so over here, remember, we put this together. This is the right side. Here my thumbs are. This is the left side. So this is the tricuspid valve, and this is the bicuspid valve. So something that can happen is something called stenosis. So stenosis just means narrowing. So if we get a stenotic bicuspid valve, for example, narrowing, that means that there's going to be a buildup, a backup here in the left atrium. That means that the left atrium is going to have to work harder, and that means the left atrium is destined to eventually fail. Okay, so same principle here. If we get a stenotic tricuspid valve, that means that the right atrium is going to have to work harder than it needs to, and we can apply that just about any of these. If we get a stenotic aortic semilunar valve, right? If we get an aortic semilunar valve that's stenotic or narrowed, that means that the left atrium is going to have to work harder. Right? Very thick walled, but if it has to work harder, it's going to fail more easily. Okay, let's talk about maybe the opposite. So rather than a narrowing and a buildup of pressure, we can have something called valve regurgitation, so a leaky valve. So for example, if the bicuspid valve is regurgitating, that means it doesn't close completely. So the left ventricle contracts and that pushes blood back up into the atrium. So effectively the left ventricle is just kind of spinning its wheels, pumping blood over and over again. So that can lead to left side failure. Okay, so that's some failures that can happen with the valves. We've talked about the electrical conductance system, the blood flow, and I think that's about it, guys. So if you have any questions, just send me an email. Be safe out there. Make sure you guys socially distancing and all that, and let me know if you have any questions.